What's up, dogs? We're doing solubility curves, a little bit of extra review. I'm going to clarify specifically what you need to know for test and then hopefully clarify any questions you have as well. Because the big differences are why do gases and salts or solids look different with their solubility? So remember, solubility, we have factors that impact solubility. We're really looking at temperature here. Higher temps means better solubility for solids, but not for gases. Okay, so really you have to be able to distinguish these two types of solubility curves. Solubility is here on the y-axis, and on the x-axis we have temperature. So as temperature increases, notice that the lines for salts tend to go up. So solubility increases as temperature increases. And gases tend to go down. So the solubility of a gas goes down. So the question is, why is that? So let's look at these two gases, or two little videos, and then talk about what happens here. So when a salt is being dissolved in water, these water molecules kind of have to rip apart the bonds that hold, in this case, the sodium and the chlorine together. Okay, so water has an important role here. It surrounds the salt and pulls it apart. Now remember, temperature reflects motion of particles. So at higher temperature, the water molecules are moving faster, as are the molecules here, which means it is easier to pull that molecule apart. It's easier for the Na and the Cl to be pulled apart at higher temperatures. Okay, so that means that more salt is able to be pulled apart because there's enough energy there to destroy the bond between the sodium and the chlorine. Okay, so higher temps means more energy. More energy means more salt can be dissolved because the water is able to pull it apart easier and faster. So that's why, and you see potassium nitrate here increases a lot compared to sodium chloride. So not every salt has the same amount of solubility, and that has to do with the bonds between the potassium and the nitrate and the sodium and the chlorine. But in general, we do see this upward trend for salts or solids. As I dissolve a solid in water, as temperature increases, the solubility increases. Now let's compare that to gases. So right here, let's look at these two gases. Ignore the pressure part, but let's just look at the temperature part. The idea is the same here. So at low temp, notice these gas particles are moving all over the place, just like we learned in first semester. High temp, they're doing it as well, but the speed with which they move is a lot higher. Now imagine, this is a closed container. Imagine that right here at the top of each was water instead. Okay, it was water instead. Now as that gas particle hits the roof of the water, just like you see there. So let's see this particle, it hits the lip of the water, or the edge between the water and the air. It has enough energy then to oftentimes escape, right? It could leave the water. It's no longer dissolved. Now imagine that same process is happening at this higher temp. Not only do the gas particles hit the water more often, they also hit it with more speed. And since they have a higher speed and they hit the surface of the water more often, they are unable to stay dissolved in water. And that's why we see this at low temps. These gas particles are moving pretty slow, which means they can stay dissolved in water a lot easier than when they are at a higher temp or higher speed. At higher speeds, these gas particles want to leave water, or are capable of leaving the water more often. So that's why we see this opposite trend, because the gas particles, as they have more energy, they are able to leave the water more often because they make more attempts to escape, so to speak. So that's what we see right here. More energy means more gas can escape, and since it has more energy, less gas will be able to be dissolved at higher temps. And that's what we see with this downward curve. And that's really all you have to be able to distinguish between these two, is saying like, hey, which has higher or lower solubility? So which line is highest or lowest? Does this increase or decrease with temperature? So being able to say that salts increase, gases decrease, and then understanding the difference of a salt versus a gas. So like if I didn't tell you that this was a salt, you should be able to say Is this a salt or gas? You should hopefully be able to say that's a salt because it goes up. If is this a salt or gas, it should be gas because solubility decreases. So those are kind of the differences that you need to know. I know that last week, and this is probably an oversight from myself, I put in some other questions to give you an idea of other things that you could do with solubility curves. But in terms of what's going to be on the test, it's really some simple questions comparing and contrasting salts and gases and their solubility with temperature, and being able to interpret a graph. As temp increases, what happens to solubility? It goes up, it goes down, it stays the same, that type of thing. Okay, so a lot of the questions that were in the extra review for solubility curves last week before the quiz were not actually going to be on the test. So I apologize for that confusion, but you do hopefully have a better idea of why these graphs are the way they are right now. All right, guys, love you, appreciate you. Talk to you soon. Let me know if you have questions. Bye.